So as a heads up, there will be a link at the end of the slideshow with all the resources for this talk. So no need to take photos during unless you are really excited about the way I look when I'm talking about Scala. I'm curious, before we get started, who here came to Scala not knowing any statically typed language? They came from maybe Python or Ruby or JavaScript. Cool, that's actually a pretty large number of people. Who here has taught someone who fits into that category, Scala, before? Wow, that's also a pretty big number of people. Who here is anticipating that they'll need to in the future? Maybe your team just hired someone or you're looking to get more engaged. And who's here just because the talk sounded interesting and they care? Great. Who's here because they just realized they're in the wrong room and they're about to run out and go somewhere else? Phew. All right, well, since you're all here for me, let's get started. My name is Ely. I'm on the Spark platform team at Bloomberg, and I joined Bloomberg 1.5 years ago, knowing only Python and JavaScript, never having done any Java or any C, certainly no Haskell or Rust or anything like that. And but I do have a background in teaching. Before becoming a software engineer, I had several jobs that involved teaching, either officially or unofficially. And so this talk is going to be a set of observations that I've collected in my 1.5 years learning Scala that are sort of with the pedagogy concepts that I'm familiar with applied. Now, I want to tell you about what worked in how I learned, what didn't work, and also what I've learned from other people I've talked to who've been on either side of this divide before. Now, I hear you thinking, or at least I was thinking when I got into this talk, who are these people who have never taken a course on compilers? Well, they're software engineers. They're just not the stereotypical kind. Maybe they come from boot camps. Maybe they taught themselves how to code. They could be changing careers from one technical field to this one. Or they could be students who took a few CS courses in college, but were not CS majors, and so didn't get that full suite that we stereotypically think of when we think of CS students. It's hard to make truly blanket statements about what these folks know or don't know because they're coming from such diverse backgrounds. But you can generally guess that they're not going to be really hip to how compilers work. They won't have a strong understanding of type systems. I had never heard of functional programming coming into Scala. And because they don't know C or Java or Haskell, most of the resources that are out there that are introductory Scala resources are not written for them. And so they're going to have a little extra trouble understanding those without your support. You have a question?
One neat category I think is missing is data scientists.
Data scientists, that's a great one, yes. And yeah, I think a lot of the concepts from this talk will apply to that group as well. And so these are people that, for the conception of this talk, these are people you've already hired. They've proven themselves in some other way. Maybe they've done great projects. They've had previous technical work coding. And so they're definitely skilled. They just haven't had a chance to turn their aptitude into application yet. Now, you may be thinking, Ely, clearly you are a major asset to your team, but why should my team take a risk on these people who don't know the difference between public and void? And my response to that is, remember this job board from last year's Scala, by the way? If you can't see, on this side we have the people looking to be hired, and on that side we have the companies looking to hire someone. In addition to this tight market for Scala devs, you can find that this is a really rewarding experience. As they say, the best way to learn is to teach. Your team can benefit from bringing in diverse experiences and perspectives of these engineers, and you get the chance to mold these people in your image, make the Scala devs that you want to see in the world. Now tell me, who here has opinions about Scala? Exactly. Also, the Scala community can really benefit. You maybe bringing in the next Scala rock star, someone who's going to write your new favorite library in a few years. And also, let's not underestimate the value of silly questions. This is mostly a community of experts. Even when most people are coming in and learning Scala for the first time, they're already experts in a lot of the concepts that we take for granted. Beginners don't take those concepts for granted, and so they do a good job of questioning assumptions that really should be questioned and often aren't. They also, if they're asking questions, say on Stack Overflow, and we're answering those questions for them, that's lowering the barrier to entry for the next wave of beginning Scala developers, which means in a few years, you'll have an easier time hiring people. So, thought we could go through some tips based on my experiences learning Scala. And for all the tips on this slide, I feel like they can all really just be boiled down to thoughtfulness is effective. The first one I've got for you is ask how they like to learn. Personally, I love seeing examples of whatever it is that I'm supposed to be doing next. Other people might prefer that you give them something to go and read. Encourage questions. Make sure that these people know that to you, a basic question is not a bad question. And make sure you know for yourself that a basic question is not a bad question. You want to be their resource for the fundamentals. You want to make sure that they know this stuff. And also remember, they may come to you with the same question multiple times. It takes multiple exposures to really learn something well. And so make it clear to them that you will not be offended if they ask you something really similar to what they asked you yesterday. Check in mid-lecture. Don't waste your time by rambling at someone for 10 minutes when the first thing you said didn't make sense to them and you lost them right out the gate. Questions that I like to hear when people are teaching me things are things like, did that make sense to you? Do you want to try explaining that to me so I can make sure you really got it? Is there anything else that isn't clear to you? Stuff like that. Even before you start lecturing, check in to see, do they actually need this lecture, or do they already understand this concept that you're assuming they don't just because they're a beginner? Dig up resources. They got the job. They know how to find resources. Making them go and find them is not making them stronger developers. It's just wasting their time. One time, a coworker was giving me some suggestions about some code I was writing, and he said this would be a good place for a map. So I go and I spend 20 minutes finding resources on the map data structure, and then I spend an hour trying to figure out how this could possibly fit into my code. Well, of course, he was talking about map as a method, but that was a lot of time wasted for me, and that was 2 concepts that I had to pick up right away instead of just the one that I actually needed to get the job done. Set timelines. So this is, make sure that they know, and make sure you know for yourself, timelines are not to grade someone or to judge their performance. It's more about setting expectations for them. Letting them know, I think this project is going to take you a while, or this should be really fast. If it's not really fast, come talk to me because there's something else we need to figure out. Model good code. This means writing tests. This means writing clean, clear, readable code. This means being explicit about your types if there's if there could be some uncertainty in the beginner's eyes. This is writing good documentation and examples. All these things that are really good for you to be doing anyway, but are especially meaningful when this person is not going to be able to make all the assumptions that you would expect a expert developer to make. And also, it's modeling good code. It's teaching them how you want them to be writing code. Finally, introduce them to the community. This is good because it lightens your load. It also exposes them to a broader range of topics than they would get just at work with you. And it's a good way to convince these people that you have friends. So those were my do's. Let's get into just a couple of don'ts. The first one is, don't say, oh, Odersky has a great course on Coursera, and then disappear for 2 weeks. It happened to me. I've seen it happen to other people. It's not a good way to start. Never say just. And what I mean by this is be really careful about the tone that you use to tell people, to give advice to people. There's a huge difference between someone saying, but it's so simple, which feels really awful, or it's actually simple, let me show you. The second one is, I know you can do it, anyone could do it, but I'll show you how so that then you're strong at it. Don't mistake inexperience for incompetence, and relatedly, don't mistake vocabulary ignorance for conceptual ignorance. So let's talk about the first project that you give one of these new coders on your team. I'm speaking completely from experience here. I feel like I sort of had about 3 first projects. Some of them went excellently, some of them did not. 1 went excellently, 2 of them did not. And yeah, when I say first, I actually mean the first few projects. In my experience and in my opinion, the very best way to start someone out is writing unit tests. You can have a couple there that they can use as a model, and then it's a way to introduce them to your code base. You're giving them quick wins because unit tests are quick to write, and it's an instant feedback loop. If they can get the tests to pass, then they know they've done things correctly. Next best would be partially complete projects, something where you've already determined the structure of the project, you've made all the big decisions, and you've even written some of the code so that they can look to that as an example for what to do, and you have a strong idea of where it's going so that you can support them if they come to you with questions. Also great can be warm-up exercises, although there you lose the awesome experience for them of contributing right away to the code base, and you also lose for you the lessening of your workload that can be. Small projects, just in general, keep things small. You don't want to let people go down the rabbit holes that like behemoth projects can give you. I have found, and this was one of my first projects that didn't go great, dependency upgrades seem so simple, and yet they're simple to you. They are not simple to someone who doesn't know the dependencies, who doesn't know the code base, who doesn't know your deployment system. It's just, I don't recommend it because what takes you half an hour and feels like nothing could take them a week, and they're spending that time knowing you expected it to go faster. Also bug fixes and just bad code in general. First of all, you're not modeling great code for them. And also those are the sorts of things that if it's tough for you to find, it's gonna be super tough for them to find. And even if it's easy for you to find, they're not familiar with your code base, so they have to learn a whole lot just to solve one small problem. I also don't recommend concepts new to you, both because who are they going to go to when they have questions? And then also because in working through this problem, they may hit a point where you would have realized this is not going to be possible to do, and they won't know enough to say that, and so you can send them down some really deep and unpleasant rabbit holes. Just in general, the category of like stuff you don't want to do, I find contains the best possible projects to start someone on and the worst possible projects. So don't use that as a guideline for what you should give people, but do, be really grateful if the stars align and this thing that they're going to be really excited about and learn a lot from is something that you would just as soon not do because it feels tedious. So I know, this is a Scala conference. Where's the Scala? I'd like to give you this quote from a friend of mine. He said it to me when I found out that I was going to be learning Scala and had no idea what it was. He said, "Scala is a language written by academics. It's very clever. Don't try to learn every funky feature now. If you focus on the core, the funky stuff will come with time." And I have found that to be really great advice, really true. I think it's also great advice for people who are planning on teaching Scala to consider. So going into the specifics of what that means, these are my suggestions for what you should start with right out the gate. It's cool if y'all disagree. If we have time at the end, we can have a bit of a debate about it. But I really encourage you to start with types and type signatures. This is just not necessarily going to be clear to people who come from a dynamic language. Also, tools, like I said, this is your chance to mold someone in your image. If you have a favorite tool, they will have a favorite tool and it'll be your tool. My one exception to that, or my one caveat is please don't make them do Vim or Emacs, even if you're a Vim or Emacs wizard. There are so many awesome things that IntelliJ gives a beginner that it can speed up their learning so much. Functional programming basics, like Val, not var. Feel free to just give orders here, and you can do the explaining as it comes up or as they ask questions. What is an object versus a class versus a trait versus a method versus a type? These are things that probably feel really obvious to you, and at this point they feel really obvious to me, but a year and a half ago, very confusing to me. And a couple of talks with some coworkers who were more comfortable with it really set me on the right path and made coding in Scala a lot easier. Compiler basics, and by basics I mean, what is a compiler? Don't have them writing compilers. And finally, options. This is a personal opinion, right? So now let's jump on to things that I wouldn't recommend right away. Monads, implicits, currying, anonymous functions, case classes, recursion, compiler intricacies. You may be looking at this list and something on it might feel like, but that's a core feature of Scala. My life is so much better because I can, use implicits or case classes or something. And I have a little story for you to make my case for why you should hold off on these, which is that when I joined Bloomberg, I probably had case classes in the first 8 months explained to me maybe 3 times. And not long explanations, but enough that it was clear to me that the person explaining it was really excited about case classes. And I just didn't care. And I knew what they were if I saw them in code, but I would never write them into code myself because it just wasn't clear to me why one would do so. Then, of course, I submitted a pull request that had a type that looked something like this in it. And my coworker sat down with me and said, I think this would be a perfect case to use case classes. And so he spent 5 minutes with me, went through, and we replaced this with case classes, and it blew my mind. And I was so excited, and now I love case classes. And I recommend waiting for those moments where you can actually make the person you're teaching feel really great about the thing because you're going to be making their lives easier. So that's pretty much what I've got. This is the slide that I recommend you photograph if you'd like to go to this link up here. There's a write-up of this talk there. There are also a collection of resources that I have been putting together over the past year and a half as I've been learning that are things I have found you don't need to know Java to understand. And so if there are any learners in your life, I totally recommend sharing those resources with them. I welcome contributions to here if you'd like to go in and add some of your own learnings or add other resources that you've found. And I just want to close by saying that most of us aren't full-time Scala instructors. And in the short term, putting effort into pulling junior devs into the Scala fold can feel like a trade-off against other urgent demands on time. But if you approach this process with intentionality, that can mean a smoother ramp up for your learners now and then a more effective, appreciative teammate in the future. So that's what I've got. Do we have any questions, or does anyone want to debate me on monads?
So I have one question, especially for beginners. In the modern, currently, you want to start developing something, you want to do something exciting. Typically that involves some libraries, JSON thing, some web framework. Scala does not have something in the standard library. And there's so much to choose from existing libraries that offer these functionalities. How would you recommend a beginner chooses one of these libraries? Or that you choose one for a beginner?
I think I have 2 answers to that question. One is my answer for beginners, which is sort of do what's sitting right in front of you. As you get more into things, you'll have a better understanding of the space, and so you can make more decisions. But if you've got a coworker who says, we need you to ramp up on this, they're ready to give you the support and resources to learn this, whatever it is. As the mentor, as the teacher, I would say, remember that to these people, all of this stuff feels really new. So writing tests may feel really dull and like something you have to do. I mean, I don't really feel that way still, but I know people do. But for a beginner, and when I was a beginner, it was so gratifying to have this tiny little thing done. And so it was less about learning the hippest new technology and more about getting a sense of mastery of something as quickly as possible. Does that answer your question? Cool.
Cool, thanks. One more question? Anyone else have a question? I thought someone.
So,
Too, I just yelled it out.
okay, so about case classes, how they are supposed to kind of model data structures if they don't know case classes with H-list?
I guess I have two answers to that. One is, what are you asking your beginners to do? There are ways to get around case classes. For example, ugly stuff like this. If you have a specific use case where you really can't get around it, go ahead, introduce them. This is more a suggestion about not introducing concepts because you're excited about them, but introducing them when they are useful for the situation at hand.
Okay, thank you.
Thanks, Jan.